Hello friends, uh, welcome back to my channel, which is um, about basics of structural analysis. So, in continuing our discussion, in last lecture we discussed about the equilibrium equations and why they are important. So, while we were solving some examples, we saw that we understand few points from that. Say, a structure is something which is supposed to take load, and the way it takes load, is all we concern about. How it receives load and how it transfers it to the ground. So, what a structure does, it receives loads and it transfers to the ground. And how it do it? It does it by transferring the load via members. Suppose this is a load which is acting over it. It is being transferred through this beam. Then this beam transfer this load to this column, and ultimately this supports give reaction to maintain its equilibrium. So we already know about three equations of equilibrium. What are they? Summation of Fz equals to, suppose we are talking about in a 2D plane. Say this plane is x, this axis is y, this is x and y. Okay, so if we are considering the equilibrium of forces along the x-axis, say this is our equilibrium equation. Equilibrium of forces along the x direction should be 0. Net force should be 0. That only then this our object will be in a rest position. Similarly, in the y direction, there should not be any movement along the y direction also, so it should also be balanced. Summation Fy should also be balanced. And one more thing we knew, that structure is, whichever structure we are considering in that 2D frame, it should not be rotating like this about any point. Maybe about this point, maybe about this point. Any structure on this plane is not supposed to rotate about the z-axis if we considering a 2D system, two-dimensional, a planar system. Okay, so in that case, summation mz should also be equals to 0. So this is for 2D. These are three equations of equilibrium for a 2D structure for each part of it. Suppose there are two parts which are made up of suppose there is a structure which is made up of two parts like this. Say it is a fixed support, it is fixed here, it is pin, a pin must be passing through this, so that these two members are connected with each other, and this could be the other support, and maybe it is also fixed. So that kind of support, this kind of support, this kind of connection of two members, I can illustrate to you with this pencil sharpening knife, and you can see that this is a knife, and it is of two parts. I am actually I'm holding camera with my another hand, so that's why it's difficult to perform some operations just by using one hand. So this is also, you can see this, if I'm putting it here, then it is rotating. So rotation is not restricted in this internal pin. It is an internal pin, and it can be a hinge support also. How? Suppose I'm fixing this somewhere like this, and then the member connecting this member is not free to move in this direction, nor free to move in this direction, vertical and horizontal. You cannot move this member out of this pin. So this is a hinge joint. And are you getting my point? This is a hinge joint or hinge support. In that case, you are familiar with this kind of diagram, but they are same. This is hinge. You cannot pull this out of that. You cannot pull it in perpendicular to that direction, in perpendicular to this. So that is a hinge support. So I can show you what are the notations of them and what is the meaning of them. So first of all, I'm showing you a fixed support. What is a fixed support? A support which is fixed. Okay, a support which is fixed. Wait a minute, I'm just okay. So what I was doing, I was just showing you some supports. So suppose this is a fixed support. A member is fixed here, just like this is a cantilever beam, and it is fixed. So what will this support will do? How it provides support reactions? It provides, see, this is a vertical reaction you can find here. You will get here whenever you place a load. If there is no load, there will be no support reaction, but there will be some support reaction because of this weight of member. It also needs some support. So this is also a vertical reaction. This is a horizontal reaction, and this is a moment reaction. See, these three are support reactions. So if there is a fixed support, you will get three support reactions for a fixed support. Okay, what about the hinge support? Hinge support, as I illustrated you earlier, it is just a pin which is supporting a member over it. See, remember this? You cannot Suppose if this support is fixed to the ground, then you cannot um, pull this. You will find resistance if you are pulling this member from this support in this direction. You will get some support reaction. You will find some resistance to pull it out from this hinge, as well as you will find you cannot pull this member in this direction. You cannot pull this blade out of this hole in this direction. It will offer you some resistance. Okay, so you can try this if you have all you need just a little knife, and but you cannot get some support reactions if it is a moment. You see, if a load is applied in this direction, it will keep on rotating, it won't resist it. But if I am trying to pull out this, it is resisting. It is rotating right now because I'm applying a moment on it. But see, if it is completely vertical, I cannot take it out from that direction also, neither this nor that. So there will be some rotation, and the reason behind that, it do not offer restriction or support reaction to rotation. So it will provide a vertical support reaction, it will provide a horizontal support reaction, but it won't provide a rotation. It won't resist rotation actually. So this is a fixed support. This is hinge support. What other kind of supports you have seen? A roller support. What is a roller support? A roller support is just a simple support which offers a reaction only in single direction. Suppose this is a ground and there is a roller on it. See, this is a roller. This is on ground. So what will happen if this is a roller? It can be a cylinder. It can be a cylinder, it can be a sphere. Okay, so if you place some plate over it, see, if you place a plate over it, what will happen? The plate won't go in this direction. This plate won't go direction perpendicular to it where it is lying. So it will give some restriction, it will offer some reaction to whatever vertical load is applied to it. Okay, so if you are getting my point, what I mean, but if you apply a horizontal load over it, it will just move, it won't resist. See, for example, see, this is a pen, it is cylinder, it is rotating. So if I am applying some load on it, see, this is a load which I'm applying on it, it is not going down. This object is over it. It is not going down direction, going in down direction. See, it is not going, but it cannot resist it from moving in the direction, horizontal direction. See, it is free to move in horizontal direction, but it cannot move in vertical direction. And since it cannot move in vertical direction, it is getting support reaction in vertical direction, but not in horizontal direction. No one is restricting it. You can see. So vertical reaction is perpendicular to it, and this kind of support is called roller support. How we show it? We can show this just like a symbol. This kind of symbol you can use to illustrate. It offers a vertical reaction. So vertical reactions only. It cannot offer you rotation, a restriction to rotation. See, if I'm placing load on it, it is rotating in both direction. See, so what it provides support reactions only in vertical direction. Rocker support is also similar to this. It is just a rocker attached to member and which is over rollers. So this is also a symbol. This is a rocker support. This is roller support. See, a roller support. So what they do, they offer reactions only perpendicular to them, only in vertical direction, or the plane, suppose it is inclined. Suppose this is an inclined plane and I'm making a support reaction on it. I'm creating a support on it. It is a hinge support, and this is a member connecting to this, and this is a roller support. This will offer reaction in this direction, which you can further resolve. See, this will offer reaction in this direction. So you can resolve, you can incline those supports. See, so they till now what we have seen, fixed support which offers three reactions: vertical support reactions, horizontal support reactions, and a rotation also, restriction to rotation. And in hinge support we get support reaction in horizontal direction, in vertical direction, and in roller support or rocker support we get support reactions in only one direction, which is perpendicular to the member. So which is perpendicular to member, or else we can say, suppose this is also a structure and it is being supported on roller support. See, this is roller, this is also roller. See, these two are roller supports, and suppose this is also a roller support. So how will they give reaction, support reaction? They will offer support reaction in this direction perpendicular to which they are placed, in this direction, so you will get this kind of support reactions if you are applying roller support. Hope you are getting my point, what I'm saying. So there are some other support also. Support like when we connect two members, see this, these are two members. This one is plastic one, orange for plastic, and this one is a metal piece. So these two different members are connected with each other, and they also, if I'm holding this and applying load on this metal piece, then this hinge will also give some support to this member. And how can we write that? So see, this is an internal pin support. So internal pin or internal hinge, we can say internal pin or internal hinge support, pin or internal hinge. Okay, so internal pin or internal hinge support. So see, if this is a member 1 and this is a member 2, which are connected with a pin and are supported adequately, then this internal pin also offers support reactions to other member. Both members get support from this pin due to this pin from another member. So we can split it into two parts and say if it is node A, it is node B, it is node C, then we can write it as in free body diagram. We will get three support reactions here because it is a fixed support, and namely I'm just saying this is AY support reaction, it is AX, and this is MA. Just random notations I'm using. So there will be two support reactions. This internal pin won't let this member to move in this direction just because of this member, and similarly in this direction also. So we will get some support reactions, and at B we will get a BY, a BX, this is BY, this is BX, and it will equally be applied on other member. This will also be BY, this will also be BX, and they will also act on that BC portion of or second member. This is first member, this is second member, and there will be C support which is also fixed, so we will get some CY, CX and MC. See, you are getting, this is the pre-body diagram. Okay, so it is internal hinge support. The last one which I should like to mention, no, not last one, but there are two more supports. Gliding roller. See, it is a roller which is in between two rail, and it can move in this direction. This roller can move in this direction. Suppose it is packed in this, in between these rails, and this is a wheel, it is rotating in this direction, but it can offer support reaction in this direction. Okay, so it won't provide a support reaction in the direction which is in which direction it is moving, so it will offer support reaction in this direction. It is a guiding roller. Take a guiding roller support. There is one other kind of support which is a spring support. What it is? A spring support is like roller support in some other ways, because it is, say if this is spring in this cylinder, and this cylinder is free to move in this vicinity, and these are two parts and which are connected with the spring, some sort of spring, and in such a way that whenever the load applied on it, it moves in vertical direction, downward direction, so it won't give support reaction in the vertical direction, but it can easily hold the member in horizontal direction. So in that case we will get a horizontal support reaction but not a vertical support reaction. Getting? See, suppose I'm writing a general case which could have so many supports in it. So let me draw a number from here. It is a fixed support, it is a internal pin support, then it is next member connecting to it, and I am giving it some rocker support, and then I am giving it say spring support, getting, and then I'm giving it some other kind of support. What kind of support is left? Hinge support. Okay, so normal hinge support. So this is suppose a given structure, so there will be some support reactions. You can give notation to them. I'm just showing you those support reactions with arrows. You will get a vertical reaction in fixed support, you will get a horizontal reaction, you will get a rotation restriction, you will get a vertical reaction here, you will get two support reactions in internal pin, you will get a vertical reaction here. Now it won't give you vertical reaction, it will move in vertical direction, but it will give a horizontal reaction, remember, and it will give you two support reactions in vertical and horizontal direction. See, so I hope you like the way I show you how the various support uh, interacts and how they transfers the load. See, so see you in the next lecture. Thanks for watching.